Hi, everyone. Good morning. This is awesome. I've never been on stage with a fog machine before. It feels like I feel like a rock star. So today I'm going to talk with you a little bit about the future of augmented reality, more specifically augmented reality glasses, and how developers will be able to take advantage of these, and how Qualcomm as a company is enabling and accelerating the pace of innovation to make this all possible. So I am a product leader within Qualcomm. I am leading the technology initiatives around our developer products, our developer ecosystem, and I'm going to share a little bit about hardware today, but I'm also going to talk about the software and ecosystem work that we're doing. So at Qualcomm, we are a big part of how enabling the XR ecosystem. We are building the software and perception technologies that enable these XR devices like VR headsets and augmented reality headsets to work. We're also enabling, of course, the core chipsets, the silicon and technology that's in them that power them. And then we're also creating blueprints, foundational blueprints that device manufacturers can use so that they can build a device more rapidly and bring it to market in a way that is going to reduce that time. And so we build these blueprints, we create those and give them to the manufacturers and allow them to use those to rapidly get to market. And then we're also building ecosystem software, technology that we put in the hands of developers and creators to allow them to take advantage of this amazing hardware that is being created. Now, Qualcomm is not new to XR technology. We've been working in the space for about 15 years. It all started back in 2007. We were working on AR for smartphones. Obviously, that's evolved incredibly. You know, today we're using millions of people are using AR on modern smartphones today. But we got started in head-worn AR and virtual reality very early, back in 2013 to 2015. And we worked with one of the early pioneers, ODG, to build augmented reality glasses on the chipsets, the technology that was available at the time. And then we realized that it was going to take a little bit longer to get augmented reality glasses to the point where we knew we needed them to be. So we shifted our focus to virtual reality. And we said, what if we could cut the cable and not have to use the PC to power the virtual reality headset? So we started working on standalone virtual reality back in 2015, and really that accelerated that innovation and worked with manufacturers, folks like HTC, folks like Meta, Lenovo, and others, and we were able to help cut that cord and deliver on that. So today we have millions of people using virtual reality for consumer and for enterprise, as Jason was just talking about, all enabled through the work that Qualcomm did 5-7 years ago. Now, we also, more recently, have invested in augmented reality where the smartphone plays a critical role. And that's what I'm going to be talking more with you about today, where the phone and the glasses work in tandem to create the experience. Now, Qualcomm is powering today over 60 devices, virtual reality, augmented reality devices. Predominantly, these are mostly VR, and this is because the technology that's available today was more relevant for virtual reality, just the displays, the optics, the processing technology. This technology has been here. It's a little bit bigger form factor, so it's a little easier technology-wise to make it possible. But we've spent recently a whole lot of time thinking about what can we do to really make augmented reality happen like we did for VR. And there are a number of significant challenges for building augmented reality glasses. So everything from, of course, the form factor is very, very small, right? So as you reduce the size, we want these to look stylish. We want them to fit well. We want them to be lightweight. We want them to be ergonomically good, but we also don't want to compromise on the user experience. We want that to be strong. And so how do you take this technology and miniaturize it and make it possible to run when you have to have sensing and processing and connectivity? You have to have a battery. You have to have a whole bunch of technology that you fit inside these devices to get us to this augmented future that we all want to be in. So 3 weeks ago, we made a major technology announcement around this, a new chip called the Snapdragon AR2 Gen 1. And this is the first in a series of chips we're building from the ground up specifically for enabling the augmented reality market. So this is a first of its kind. There's no other companies that are building this kind of technology and enabling it today. So I'm going to show you a quick video that will walk you through a little bit of that platform.
Oh, yeah.
Does that get you excited? It's happening. So one of the things that I mentioned earlier is that we're using a distributed architecture where the smartphone plays a role in computing. So the applications and content actually run on the smartphone, and the glasses render those. They do processing, perception, other things. But within the actual glass itself, as you can see, we're also distributing the architecture. Now, we're doing this in order to distribute the thermal load and reduce the number of wires that need to be running through the glasses so that we can get to these smaller form factors. So traditional glasses that have been built to date have been a single chip solution. This is where you have the processor on one side, you have the cameras, the sensors, the battery, all having to run across the hinge. This creates a bigger hinge. It creates, obviously, more heat on one side of the glass. And so that's not going to work in order to get us to where we want to be with future devices. So we realized this and started working early on with the Air 2 to reduce this size. So you can see the kind of difference here between a single chip solution and what we're doing with the Air 2. The PCB, the board itself, is 40% smaller. The 45% reduction in wires that have to run over the hinge. Now, so we're doing this. Let me just dive in a little bit to each of those processors. The first is the Air processor. This is the device that's doing a lot of the perception technology, so tracking the hands, tracking the user's location in an environment, running the algorithms that enable content to be locked into the real world or scan the real world and create a 3D reconstruction of it so you can introduce AR content and it interacts with the environment in a real and convincing way. And then we have this processor in the middle. This is a co-processor. The purpose of this is to take all the camera feeds from the eye tracking cameras and the positional tracking cameras, route them into a single processor so that you have less wires that are running over that hinge. And so this enables us to reduce the size. It also distributes the thermal load because now more of that processing of those camera frames and other things can happen in a different processor, and that leaves the other one to not have as high of a workload. These are just I want to show you a couple of graphs of what we're seeing. So this is performance and memory usage, power consumption. So the device on the right is the AR2. What these little dots are when the glasses want to, let's say you want to position content in the real world, you need to track the position and orientation of the headset in real time, and it does that by extracting different features from the environment, and then it tracks the location of those features relative to the headset, and this is what allows you to determine the location of the user and then position content in the world and have it convincingly, lock there. So you can see, as you can see, that was an indoor use case. We're also doing it outdoor. I'm going to talk a little bit about some of the work we're doing with Niantic. Obviously, they're very focused on outdoor, but you can see a really, really big step function gain in terms of successful relocalization outdoor, much lower latency, much more lower memory throughput. So the last part is connectivity. So we're doing Wi-Fi 7, which runs in the 6 gigahertz band, which allow for really, really high bandwidth connectivity. You can see that the bandwidth itself, or the latency of the link, is less than 2 milliseconds, 5.8 gigabits worth of speed. We're displaying the content from the glasses from the smartphone to the glasses. This requires an extremely high bandwidth connection. It needs to be really low latency because from the time that a person, let's say, moves their head a few centimeters, we have to send those frames to their position of their head to the smartphone. The smartphone has to render that frame. It has to encode it and send it back and then reproject it. And that whole loop has to happen in like 9 milliseconds in order for content to not be jittering around. And so by having a high throughput connection with Wi-Fi 7, we can enable this. And we're doing it all at less than 1 watt of power, which is amazing. Really, we want these glasses, in order to get to what glasses we wear today are 30 to 40 grams. The glasses that are in the market today are 130 to 300 grams. So we have an order of magnitude reduction we need to do, and a lot of that has to do with power and heat that needs to be dissipated. We're working with a bunch of manufacturers here to enable these glasses. Here are some of the ones that we're working with who have shown put their support behind the AR2. Devices will start coming in late 2023, early 2024. Now, what is this hardware without an ability to do something with it, to enable an ecosystem of developers and creators to be able to build on top of it? And this is what Qualcomm is doing with Snapdragon Spaces. So Snapdragon Spaces takes the technology that we previously reserved for the OEMs. These are perception technologies that understand how to track the user's hands, how to track their eyes, how to determine their location in a room, and anchor content in the room. And we took that technology and we exposed it to developers in game engines. And so this is a technology that's available today. We made it generally available to the development community back in June, and you all can work with it. And I'll talk a little bit more about it. It's built on OpenXR, so it's built on open standards. We think that the future of development should be open. And so we're really excited about the work we're doing in Kronos in support of this. And then we have engines, SDKs for Snapdragon Spaces for both Epic's Unreal Engine and for Unity. Now, the Unity SDK also supports AR Foundation. So if you're developing on AR Kit or AR Core today, you can bring and you're building on AR Foundation, you can bring your applications right over to Spaces. Obviously, there's some differences on the interaction. You're not, pushing on or you're not typing on a screen. You're going to be interacting with your hands or with a raycast. But with slight modifications, you can bring your applications from other platforms over to Headwarm. Now, we started in augmented reality with the Lenovo A3. So Jason was just up here talking a little bit about the work that Lenovo's doing. Amazing work there. And we're moving it to also mixed reality and virtual reality. So what this means is you'll be able to build an application on mixed reality and bring it to these optical see-through based AR glasses or vice versa. So we think this is a really important unlock for the ecosystem. This is an example. It's kind of an engineering demonstration, but on the left you'll see an application that's running on an optical see-through AR glass, and on the right is on a mixed reality device, the same application that runs across both. So really, really cool stuff. And then how do we make these smartphones and glasses work together? We have something called Snapdragon Spaces Ready, and this is a program to certify the smartphones to be compatible with glasses based upon our existing chipsets as well as the future AR2. And these are some of the manufacturers, the OEMs, that we're working with to make this possible. So this is enabling the underlying connectivity, but also enabling the smartphones and the applications running on the smartphone to be able to work in collaboration with the glasses in a seamless way. Now, we really believe that not only should the platform be open, but the ecosystem should be open. And we're working with companies like Microsoft and their mixed reality toolkit team to enable their open source software on Snapdragon Spaces. And so I want to play a quick video here, show you some of the work that the MRTK team have recently done with this. So MRTK, for those who aren't familiar, is an interaction toolkit. It allows you to kind of standardize the UI and the way that you interact with those in virtual, augmented, and mixed reality. This is a little bird called Flappy, and if you put your hand out, Flappy will come fly to your hand and perch on it. So it's just a little demonstration application that shows off some of the user experience there. But I think it's important to say, hey, this is an open source project, and it helps make interaction interoperable across devices. And we want to be, as Snapdragon Spaces, we want to be working with interoperability. We want to be supporting openness and platforms. So another company that we're working with in this space is Niantic. And you may have heard that Niantic is doing work in head-worn augmented reality. We've actually been working with them for several years, and they recently unveiled a new headset reference design that we've been collaborating on specifically for head-worn augmented reality in outdoor environments. Obviously, Niantic are the creators of things like Pokemon Go, Pikmin Bloom, and those are about getting people outdoors and interacting with the real-world metaverse. So how do you overlay content on top of the real world in places like parks or in different places you may be exploring? And so bringing this technology outdoors is a whole nother level of challenge, and we're really working with Niantic to solve this problem. What I'm going to show you next is a through-the-glass demonstration on a prototype of this headset, showing off some experiences from Niantic. But before I do that, I want to note that we're working with Niantic closely to enable what their technology called a visual positioning system. And what that does is allows you to, it's sort of like a compass for tracking your location outdoors. And it's really important to render content in an accurate way outdoors that you know the precise centimeter location of a person's head at any time. And so what Qualcomm and Niantic announced is that we're going to work together to enable Snapdragon Spaces and Niantic's visual positioning system to work well together. And so we'll be announcing more about that for developers later in 2023. So here's a quick video that shows off a little bit about what we're doing. All right. Super excited about this work, and like I said, more will be coming. We'll be announcing more about this next year. And we're not just working with some of the larger players, we're also working with many, many developers out there in the ecosystem, both for consumer and for enterprise. So, this is a sample of some of them that we're working with, but the list is very, very long. We're really excited about the support we've had for Snapdragon Spaces in the ecosystem. One I want to highlight here is a company we've been working with for about a decade called Trigger, and beginning in smartphone AR, but now for head-worn AR. And they approached us about a project working with the music group Duran Duran from the 80s. You might remember them. And they wanted to augment the world and create a really special experience. And so we worked together with Trigger to build something for Spaces. I'm going to show you a quick video of what we did there.
From the very beginning, when we formed Duran Duran, technology was important to us. We weren't the kind of band that just put on jeans and a t-shirt and went and played our songs. It was all about the overview. What could we do together as a creative unit? We've always tried as a band to use our music to change people's worlds, to transform their audio space into a new reality. We're always still searching for that wonderful opportunity to do something new with technology. And so Qualcomm came along with Trigger designing an augmented reality. And it just seemed like a great combination. If you put on these rather beautifully designed glasses, it's Duran Duran's music in a different universe. It's a different dimension. You can touch the music, you can change the music, hear the music in different formats, and hopefully you'll have some fun too. Snapdragon Spaces is the platform that made all of this happen.
Snapdragon Spaces provides an open platform for developers to create immersive experiences using the latest perception technologies on emerging XR devices. We're excited to be working with innovative creators like Duran Duran and Trigger to reimagine reality.
This kind of technology enables you to take things to a completely different level. It's immersive, it's interactive, and it feels very new. This has been a really exciting process working with Snapdragon Spaces to bring this augmented reality to become a reality in our world. It's a whole different level, it's a different experience, and it's only the beginning of what we're hoping to do. I think this augmented reality project is really the first of its kind, and I'm so excited to see how much further we can push it. This is Duran Duran Reality Reimagined, so come and join us.
All right, so that was a really fun project. So I'm a little over time, so I'm going to just get through a couple more slides. How do you work with it? So there's a development kit. It's the Lenovo A3 and the Motorola Edge smartphone. You can go get that at spaces.qualcomm.com. Go to our dev portal, download the SDKs, and get building right away. So With that, I just want to thank you all for your time and encourage you to please come take a look at the work we're doing, the community that we're building. Really, this is the future of immersive. This is head-worn AR is where we want to be, and we can't build it alone. We need to build it with all of you. So look me up. I'll be here. Feel free to LinkedIn, connect with me, or at the conference. Find me. I'll be here through Wednesday, and look forward to having you join our community. Thank you so much.